Okay, so here we go. Problem number 8 on your homework 4.4. And once again, we have an exponential equation here, and we would like to solve for x. And so now, with this equation here, this number 8 right here, starting with number 8, that would be the problem where you need to use method number 2 to solve your exponential equation. Now, reason being, you can try to apply the same trick that we have had in the past 7 problems. However, here's the case. 9, you can write it as 3 squared, okay? That's good, I'm all fine with that. 26, the problem here is you cannot find any better power for that. So 26 itself is a 26 to the 1 power, okay? 26 to the first power, you cannot find any better base for that. You cannot find any smaller base of that. So, or you can just simply leave 9 to the x. You can just simply leave 9 itself. That equals 9. Because the point is, no matter what you try, you just cannot find the good common base on that. So now, for this equation here, I'm going to use method 2. Use method number 2 that we discussed in the general discussion for section 4.4. So what I'm doing here is that my equation 9 to the x equals 26, right? What I see here is that I have a power 1 on the right hand side. And so my number 9 right here is the base, and that's raised to the x. So what I can do is simply I take natural log of 9. Okay, on the left hand side, I'm doing it again. I'm taking the natural log of 26 on the right hand side. And then for the left hand side, my natural log of 9, I'm going to multiply that to x. Now where did x come from? X came from the power of my left hand side. And then times 1, which is the exponents on the right hand side. So here I produce for myself a new equations. So looking at that new equation here, what I have here is, once again, please think of the natural log of 9 here as a one new number. And so my equation will look like x times natural log of 9 equals natural log of 26. And once again, 26 is another number, some kind of existing number out there. And so to solve for x here, all you have to do is just divide both sides by natural log of y. Natural log of y. And that would give me x equals natural log of 26 over natural log of 9. Okay? And so how I can find the real final answer? And of course, please, once again, do not expect that the answer has to be looking like a whole number or something like that. It doesn't have to be a nice looking number. So what I have is natural log. Okay, I have natural log. I'm doing natural log of 26. Okay, and I'm dividing that by natural log of 9. Okay, all that expression here gives me 1.48. So after 1.48, 28, whatsoever. So rounding that all to 2 decimal places, that would be 1.48. So my final answer would be x equals 1.48. Okay. Now, similarly, for problem number 8, you can also alternatively, problem number 8, let's try to reinvent the way to solve this problem again, okay? Now, in the general discussions of section 4.4, I have not mentioned, however, here is some more additional details that you can try again, okay? Do we always have to use natural log? The answer is no. So, starting again, I'm solving this equation here for 9 to the x equals 26, okay? Do we always have to use natural log of x? No. You can also do log base 9, log base 10 of 9. And then you do log base 10 of 26. And that's going to give you the exact same answer. And then whatever that base is, you multiply with the x in front. And that equals, the power here is 1. So times 1 on the right hand side. So I have x times log base 10 of 9. Sorry that I have said log base 9 earlier, but actually what I meant was log base 10 of 9. And equals to log base 10 of 26. Okay, so now once again to solve for x, think of log base 9, log base 10 of 9 is just simply a number, one existing number. So dividing log base 10 of 9 to both sides, and that gives me x equals log 26, log base 10 of 26, divided by log base 10 of 9. And that gives me, once again, my calculator. Let me show you how the answer is supposed to be precisely the same. So I would do, on my calculator, I do have the options to do log. Okay, so log of 26, close parentheses, we would like to divide by log base 10 of 9. Okay, and dividing on that here, I do have to look at the two answers here, they are precisely the same. So my answer for this problem will be 1.48. Okay, that's how I solve my problem. So if you wonder, why did I not use log base 10 in the beginning of the line? Easy to answer. That was just my own preference. I like to use natural log rather than log base 10. To me, natural log would be a little more common compared to log base 10. However, on your own choice of problem, when you're solving these, you have your own right to use log base 10 in replacement for natural log, and no one's going to say that you are wrong, okay? But then as a convention to the rest of the, and to save me some time trying the problem, one same problem in two different approaches every single time, to the rest of these problems, whenever we're solving for exponential function using the log approach, I'll just simply stick with my preferred methods of using preferred log, and which is the natural log, okay? So now getting into problem number 9. Okay, problem number 9, another similar one. Okay, what I'm having here is we want to solve 7 times e to the x equals to 19. Okay, and so this is the equation here we would like to solve for x. Once again, the only little additional step that you need to add in before we can actually throw in the log is to divide both sides by 7, because my equation that we're starting out, we want it to be in ordinary form, which is simply one exponential term equals to another exponential term. Here my exponential term involves some coefficient. So right at the beginning, 7 times e to the x equals 19. I must divide 7 away from both sides. And there I have for myself e to the x equals 19 over 17. Over 7. Okay, over 7. And once again, it's 19 over 7. Sure, it's not a nice looking number, but that's not the point. We are supposed to be able to handle like not nice looking number, right? So at this point here, I can think of 19 over 7 as 1 base to power 1. And so now I can see that I can just directly use method number 2. I do natural log of e. I'm taking simply natural log of my base on the left hand side, and I multiply that with x, which was my power on the left hand side, and I'm making that equals to natural log of my fractions 19 over 7. Okay, and I'm multiplying with 1. Once again, my 1 here came from the power. And so now at this point, the good thing with natural log in this problem is natural log of e, without thinking, I can see that natural log of e equals 1. Equals 1, so I simply, on my left hand side, I have x times 1 equals natural log of 19 over 7. Okay? And so that will give me x equals natural log of 19 over 7. And so in this case, as a quick calculation, and once again, please keep in mind, this final expression right here, what I'm talking about is you need to divide 19 by 7. And then whatever the answer that the fraction will give you, you take the natural log afterward. It's not about, you cannot do natural log of 19 divided by natural log of 7. Okay? We have discussed this back in the days when we learned logarithms. And by the way, so to find the real answers, that would be natural log, and then you do 19 divided by 7, give me your parentheses. And there is the real answer, 0.9985, something like that. Okay, so x would be equals to 0.9985. Okay, that's about good enough.